This is the second part of the video, error and uncertainty. So in this video, we'll be talking about uncertainty and its relation to error. So the previous video was about error and types of error. So this video will cover about uncertainty and its relation or difference to error. So what's the main difference between error and uncertainty? So let's get started, shall we? So we all know that in the real world, we cannot measure the exact value of a quantity. Reason being, as I told you in part one, because of errors. Errors are kind of inevitable. So if you remember that in the first video, we talked about types of errors, right? So what were the two types of error? There were the one was random and the other was systematic. Now we can eliminate the systematic error, but we cannot completely eliminate the random error. We can minimize it to some extent, but we cannot completely kind of remove it. So, so that's the reason errors are kind of inevitable. We can minimize it, but we cannot completely remove it from the system or the experiment. So therefore, every measurement, no matter what measurement you do in physics, when trying to calculate measure any physical quantity, they are bound to have error. So the values will be different from each other. So errors are inevitable. So for this reason we use uncertainty. So uncertainty, what does it do? We know that measurements give off different values. So uncertainty gives us a range of values in which that measurement, the value of the measurement can be inside that range of values. So let's go ahead with the definition. So there are two definitions. Let's follow the first one, as the uncertainty of a measured value is an interval around that value such that any repetition of the measurement will produce a new result that lies within this interval. I think this might be hard, but I want to try to understand this one. But now let's first look at these with the simple words. So in simple words, the uncertainty is a range of possible values in which the actual true value of a measurement lies. So basically, it's saying that, look, we know that errors are inevitable. Every time you try to measure a physical quantity, you will have a different set of values. What uncertainty does, it gives us a certain range of values in which that measured value can lie upon. For example, let's just say, for example, I have, um, mm, for example, let's say I have 0.2 or 0.6. Let's consider just a simple example. Let's say you have a value 10.2 and 10.6. So basically, this is the min and this is the max. So what uncertainty tells you that, look, no matter how much you measure that physical quantity, it will be inside the range of 10.2 and 10.6. It can be inside the range. For example, you calculate the value and you get, for example, 10.5, or you again someone else calculate the measure the value and it goes like 10.4. So it's inside this range. This is inside the range of 10.2 or 10.6, but it cannot go beyond this range. For example, we cannot it will this won't be the case for 10.1 because it's outside the range, so the value will be neglected. The same case for 10.7. So basically, uncertainty gives you a range of limited range of values in which the measured value will lie upon. So uncertainty is essentially reliable for is essential for the reliability of an experiment. Why? Because in the recently I told you about that in the real world we cannot eliminate error completely. So that's the reason that it is really essential, because in academic or industrial piece of work, the any document regarding academic or in industry, any documents that you present will be rejected, will be neglected if uncertainty is not present in your documents or any academic paper. So that's how important uncertainty is. And uncertainty depends on the precision of an experiment. So the more the precise of an instrument, the more precise an instrument is, the less uncertainty there is. So that's why we use uncertainty that gives us a limited range of certain values. Let's go ahead with a simple example. For example, let's take the resistance of a resistor. So here we have resistance equals 4.7 plus minus 0.1 ohms. So this is ohm, this symbol for ohm, plus minus 0.1 ohm. So here, this thing right here, 4.7, this is actually the accepted value. So this is the accepted value, the accurate value, the true value. But this area, okay, but this area, this here plus minus z1, this is the uncertainty. So plus minus symbol is used in uncertainty, so which basically this indicates that 4.7 plus minus 0.1, basically we add, we first subtract, we have 4.6, and we add, then we have 4.8. So these are the values, these are the given range of the certain values. So this indicates that the measured value can be between 4.6 and 4.8. It cannot be outside of this value. It will be inside 4.6 and 4.8 ohms. So I hope you got that example correct, right? Now another example regarding everyday life. For example, you already know, I think everyone has used GPS app on their smartphone. For example, Apple Maps or Google Maps. So already know we this shape we already know from it, because if you guys have used that app. So when you are trying to locate your own location, you usually get this kind of shape, right? So this is actually, so this here, right here is the accurate location, but the circle outside it, it's the uncertainty. So sometimes you get this symbol, this little circle, but sometimes when the GPS is not navigating well, you get this bigger symbol, this bigger circle. So basically this bigger circle tells you that, look, your accurate location isn't known, but you are inside this circle, you are inside this area. You cannot be outside that circle, you will be inside that circle. For example, I can be here, or I can be just here, or I can be here. So in this all of the case, this is true. I can be here, I can be here, or I can be here, or as long as I am inside the circle, this is the GPS tells me that I am anywhere inside the circle, but I am now outside. I cannot be outside this circle. So I can be, so that's the whole reason of that bigger circle, that it says that you are inside, you can be anywhere inside that circle, but you cannot be outside of this circle. Another example, for example, let's say that you are trying to measure the width of a notebook, and you get the value of 6.0 plus minus 0.2 millimeter. So already know this is the uncertainty, 0 plus minus 0.2. So basically it's saying that you are confident that any other person or any other student or person, when he tries to measure the width of the notebook, their measurements will be between 5.8 and 6.2 millimeter, as I have write it down. So it won't be outside, it will be inside 5.8 and 6.2. So that's the example of uncertainty. Uncertainty basically gives you a limited range of values, that any measurements the value any measurement that you try to measure, and any physical quantity that you try to measure, those values will be inside those given range of values. That is basically the uncertainty here. So the next slide will be about the difference between error and uncertainty. So basically, error is kind of mistake or a fault in the error, that you are that there is there is a true value, actual value, and you are trying to measure our observed and the difference between observed value or the measured value, and the difference between, your observed or measured value does not align with the true value, then you can say that there's an error in the measurement. But the uncertainty just tells you that, look, no matter how many measurements you do, the the value of the measurement will be inside those limited range of values, and that is the uncertainty. Basically, the less the error, the more you minimize the error, the less you will have the uncertainty, the more limited range of values you will get. Let's say we have a real life example. Let's say you are going outside by a car, for some reasons. You might be going to store to buy some groceries, or some at any other place. So you go outside the house, your car is parked, and you try to unlock your car, but the car doesn't get unlocked. Why? Because you are missing your car keys. So your car keys are missing. So basically, we can say that this is basically error. Why? Because you don't have your car keys. Without your car keys, you cannot unlock your car. So that's the error. So the error is your car keys are missing. So I hope you get that idea. So error is that you cannot unlock your car because your car keys are missing. All right. Now you say to yourself, all right, I need to get inside my house and fetch my car keys. But you already know but you already know that you put your car keys inside your own room, but you don't know where you put your car keys inside your own room. So you are already certain that, let me just go to the other side so to make my point. So here, let's say this is your own room, and so you are basically saying that you are certain that the keys the keys are not outside your room, okay, but you are uncertain whether your keys where your keys are located inside your room. So it can be here, or it can be on your sofa, or can be on your computer desk. So it can be anywhere, but you are certain that the keys are not outside your room. It is located inside your room, but you are uncertain. But you already know that the keys are inside your room somewhere. So that's the uncertainty here. So the error was that your car keys are missing. The uncertainty was basically was, or you already know that you put your keys somewhere inside your room, but you are uncertain where you put your keys inside your room, and you are certain that the keys will not be outside your room. So that's the basic the difference between error and uncertainty. So this is just a short video, not short, it's already been like more than 15 minutes, I believe. So I'm gonna put end this video here. So I hope you found this video informative, and I'll see you in the next video. Okay, thank you, goodbye.